Okay, we have a trinomial here, and for trinomials we need to complete the square first. So let me write that in this way. The highest power first, minus 4x squared plus 4x plus 3. They have a common factor of minus 4, so let me factor that out. You get x squared minus x plus 3. Okay, so we get a minus 4 x squared minus x. To complete the square, I need a quarter here. Okay, a quarter. Okay, so the outside, right, I actually have to subtract a quarter, but I have to be multiplied by, this has to be multiplied by negative 4. Okay, so you complete the square, right? So negative 4x minus half squared, this is a plus 1, so you get a plus 4. Okay. Alright, so I don't like to start with a negative, so let me write it as a 4 minus 4 squared. So this, you should really look at this as a 2 squared minus 2 times x minus half squared. Okay, so let me replace with that here. We have x squared, right, 2 squared minus 2x minus half squared. Okay, all to the power of 3 over 2. Now, because we have a constant square minus a variable square, the correct substitution is to let, okay, what we have inside here, 2x minus half equal to sine of theta. Okay, but it has to be 2 sine of theta. Okay, 2 sine of theta. Then we get x minus half is equal to just sine of theta. And you differentiate both sides, you get dx is equal to cosine of theta d theta. So let's make the substitution. Okay. So x squared, right? X squared is from here. So if you isolate x, you get sine of theta plus half. You gotta square that. Okay. I think I forgot to write the dx here. Dx, okay, dx can be replaced with cosine of theta d theta. And at the bottom here we have a 2 squared minus, so this entire thing inside can be replaced with a 2 sine theta, so all of that squared, and all of that to the power of 3 over 2. Alright. Okay, so you can factor out a 2 squared, okay, or 4, right? And we get this 1 minus, okay, 1 minus sine squared theta, all to the power of 3 over 2. Okay, so if you just raise that to the power of 3 over 2, you're going to get 8. Okay, 4 to the power of 3 over 2 is 8. This is going to turn into cosine squared, so it's going to turn into a cosine cubed, okay, cosine cubed theta, if you raise to the power of 3 over 2. Okay, so now that's going to get reduced to give you, I'm going to leave 1 over 8 outside. At the bottom we have a cosine squared theta, and on the top we have sine of theta plus half squared d theta. Alright, so now, I mean, typically when you have sine and cosine, you let cosine equal to u, and you make the substitution to solve, to find the antiderivative, but we have 2 terms here, okay, in the bracket. So what we have to do is actually expand that first. So we get this. Okay, and put that all under the same denominator of cosine squared theta. Okay. Okay, so we get 1 over 8. That right there is integration of tangent squared theta d theta. Oops, sure, that should be d theta there. Okay, this is going to be, actually, you know what, that, I think you can just leave it as 1 over 8. Sine of theta cosine squared theta. Okay, a quarter times 1 over 8, 1 over 32, integration of, same as secant squared theta. 1 over cosine is secant. Alright. So this run right here, we actually need to convert that into, okay, express that in terms of secant. So you know that tangent is secant squared theta minus 1. Okay, and this one we can do it by substitution. So let me put that at the back. Let me write this first. Okay, and put that at the back. 1 over 8. All right. Okay, so the antiderivative of secant squared is tangent. Okay, so tangent of theta. Of course, minus 1 is just theta. Plus 1 over 32. This is also just tangent of theta. Okay. And this one here, you have to let u, okay, u substitution, u equal to cosine of theta. So you get du is equal to minus sine of theta d theta. So that can be replaced. Okay, that right there can be replaced with a minus, right, a minus du over u squared at the bottom. Okay. All right, so almost done. We have 1 over 8 tangent, 1 over 32 tangent. So let's add that up. It's going to be 5 over 32. Okay, 5 over 32 tangent of theta. Okay, minus 1 over 8 theta. So I just combine all these three. Plus 1 over 8. That's going to be equivalent to just 1 over u. Okay, where u is equal to cosine. So let me replace it with cosine of theta. Okay, all plus constant. Okay, so let's go back. So our original substitution was this, right? Or I guess we can just use that, right? We have sine of theta is equal to x minus half. Okay, so you can actually multiply top and bottom by 2. So if you multiply that by 2, you get 2x minus 1. You just have to divide by 2. That's 2x minus 1 over 2 with theta here. Okay, the third side here would become 4 minus 2x minus 1 square root. Okay, so what do we need? We need tangent and secant, right? Let's go back. Tangent is 2x minus 1 over this. Okay. Okay, so you get that. And I'll put 1 over 8. So this is the same as secant. Secant is just going to be square root of 4 minus 2x minus 1 squared all over 2. So I'm still using this triangle here. It's just this. Oh, sorry. Did I do it upside down? Secant is, yeah, it's actually 2 over this. 2 over that. So let me put that upside down. Right, it's 2 over, right, 4 minus 2x minus 1 squared. That can be reduced to give you 4 there. Okay. And lastly, we have a minus right here. Minus 1 over 8 theta. Okay. And the theta from right here. Theta can be just expressed as a arc sine of x minus half. Okay. So let me replace with that. Arc sine of x minus half. Okay, plus constant. Okay, so that's our answer, final answer.